Core 2, June 2013, question 2. So question 2 is a nice a question about sectors. So we start out, we've got a nice diagram here to help us, the radius of a circle and the angle. So first of all, we want to find the length of the arc. Now these formulae you need to remember. So you need to remember that the length of the arc AB is the radius times the angle, where the angle is in radians. So in this case, it's 20 times 0.8, which gives us 16. Part B is then just testing the other formulae we need to remember for sectors. So the area of the sector is a half r squared theta, where theta is in radians. So that's a half times 20 squared times 0.8, which gives us an area of 160. Question C is then the more interesting one. They've added in a line in the diagram now. And what they want us to do now is find the size of the obtuse angle ODB over here, where they've marked it on the diagram. So now we're looking at a triangle, and in this triangle we've got the side opposite to 0.8, and we've got 20, and the angle opposite that is the one we're trying to find. So that means if we're trying to find, if we have opposite angles and sides, we're going to use the sine rule. So the sine rule tells us that sine of the angle at D over 20 is equal to sine of 0.8 over 15. You can write the formulae either way up, but if I do it this way, then the thing I'm trying to find is on the top, and it makes rearranging easier. Okay, so this means when I rearrange it, sine of angle D is 20 times sine of 0.8 divided by 15. Making sure that my calculator is in radians, that tells me sine D is 0.956473, and some more. Using inverse sine with the calculator in radians, I get to D is 1.27467. At this point I have to be careful, because in the question it said that D was obtuse, and when we do inverse sine it's going to give us an acute angle. You can also check, because acute angles, you know, are between 0 and 90 degrees, in radians between 0 and a half pi, and this is less than a half pi, so this is acute. So what we've got to do now is work out what the obtuse angle is that has the same value for sine. Now you may remember, or you may need to do a sketch. Here is a sine graph that should go through 0. Okay, if we've got one angle here, so that's our acute angle, to find the one here we need to take it away from pi. So the obtuse angle is pi minus 1.27467. So D equals 1.87 to 3 significant figures, which was the accuracy asked for. So this one is not our final answer.